Okay, so now I want you to find the general solution to this non-homogeneous, this second order non-homogeneous equation. We've learned several methods for dealing with second order non-homogeneous equations. One of them is undetermined coefficients, one is variation of parameters, and one is Laplace transforms. I'm going to solve this using undetermined coefficients. Okay, but you can try to solve it using those other methods and see, see if you get the same answer, because you should. Okay, find the general solution to this. Okay, so step one, if you're using variation of parameters or undetermined coefficients, step one is going to be to find the general solution to the corresponding non-homogeneous equation. So you want to find the general solution to the corresponding non-homogeneous equation. So x double prime minus 2x prime plus x is equal to 0. And remember, we look at the characteristic polynomial, r squared minus 2r plus 1. And notice this is just r minus 1 squared. And so the general solution to the corresponding homogeneous equation is xh of t, the h just means homogeneous, is equal to c1 e to the t plus c2 te to the t. Okay, now step two is to find a particular solution. And there's kind of two steps to this process. One, we're just going to look at the right-hand side, the te to the t, and base our guess on the particular solution just on that. And so our initial guess would be, we'll have our initial guess would be at plus b e to the t. Okay, if you have a polynomial times e to the t, then your guess is going to be that a general form of that degree polynomial times e to the t. So if you have like t cubed e to the t, your guess would be the general third degree polynomial times e to the t. We have t times e to the t. T is a first degree polynomial, so our guess is going to be a general first degree polynomial. Let me just write that. This is the general first degree polynomial times e to the t. Okay, that's kind of like step 2.1. Step 2.2 is to compare your initial guess with the solution to the corresponding homogeneous equation. And there's a problem. So let's think about what we're going to be doing. We're going to be plugging xp into the differential equation and then use that information to figure out what a and b are. Okay, so if any term in xp is a solution to the corresponding homogeneous equation, when we plug that into the left-hand side, we're just going to get 0. And it's like it wasn't even there to begin with. So we have to multiply our first kind of initial guess by t until none of the terms are solutions to the corresponding homogeneous equation. So here, xp of t, as we've written, at e to the t and b e to the t are both solutions to the corresponding homogeneous equation. So we will multiply it by t. Okay, so at squared e to the t is not a solution to the corresponding homogeneous equation, but tb e to the t is, so we multiply it again. Okay, and what we get is the... Okay, and so this is equal to at cubed plus bt squared e to the t. All right, so now I need to take the derivative of xp and then the derivative of that to get xp double prime. So xp prime of t is 3at squared plus 2bt e to the t plus at cubed plus bt squared e to the t, and then xp double prime, that's just product roll, so now I'm going to do product roll on both of these terms. So this is 6at plus 2b e to the t plus 3at squared plus 2bt e to the t. And I want to take the derivative of the next term. Notice I'm going to do the derivative of the part in the parentheses times e to the t, and I'm going to get exactly this term. So I'm just going to add that there. And then plus at cubed plus bt squared e to the t. And now I'm going to kind of, in principle, plug this xp double prime, xp prime, and xp into the left-hand side of the differential equation and set it equal to the right-hand side of the differential equation. So let's think about what's going to happen. When I plug in xp to the left-hand side of the differential equation, I'm going to get a bunch of terms of the form something times e to the t plus something times t e to the t plus something times t squared e to the t plus something times t cubed e to the t. And I'm saying that this is equal to t e to the t on the right hand side. Okay, so whenever you have an expression like this, okay, the corresponding coefficients on each side of the equal sign have to be equal to each other. Okay, so the coefficient of t e to the t on the right hand side is 1. This has to equal the coefficient of t e to the t on the left-hand side. Okay, the coefficient of e to the t on the right-hand side is 0. The coefficient of e to the t on the left-hand side is 0. So those two coefficients have to equal to each other. Okay, so notice what's going to happen. If I plug in, if I see what is the coefficient of e to the t on the left-hand side, notice what's going to happen. So I don't actually literally want to plug in xp double prime, xp prime, and xp into the equation, because that just gets very tedious and messy. I just want to think about what is going to happen, like what's going to be e to the t. Like what's going to be multiplying by e to the t if I were to do that. Okay, and if I look at xp double prime, xp prime, and xp, the only one of those that has any e to the t terms is just xp double prime. Okay, and that's 2b e to the t. That's the only of xp double prime, xp prime, and xp. xp double prime has the only e to the t term. It's 2b e to the t. And so if I were to plug this into the differential equation, I would have 2b e to the t, okay, plus other stuff as well. But just if I look at just the e to this t stuff, that's all I have on the right-hand side. And this is equal to the left, so this has to be equal to 0 times e to the t. Again, because the corresponding coefficients have to equal to each other. Okay, and this tells me that 2b is equal to 0, and this tells me that b is equal to 0. Okay, so I already know that in this equation, I know b is equal to 0. All right, so now I want to look at the coefficient on t e to the t on the left-hand side. Okay, so what's going to be the coefficient on t e to the t for the left-hand side? Well, notice, okay, that xp has no t e to the t term. It's just xp prime and xp double prime. And now I want to see what the coefficient on t e to the t is going to be. So let's look at what the contribution from xp double prime is going to be. Where do I get a t e to the t? Well, I'll get a 6a t e to the t. So I'll have a 6a. That's going to be a coefficient on t e to the t. From this term, I've got a 2b t e to the t, but b is equal to 0. So I don't have to worry about that. And then right here, there is no t e to the t term at all. Okay, what about xp prime? I'm subtracting off 2x prime. What's the coefficient on t e to the t from xp prime? Well, the only one that could be would be this one right here, the 2bt times e to the t. But again, b is equal to 0. All right, so 6a t e to the t. This is just the t e to the t terms on the left-hand side when I plug xp into the left-hand side of the differential equation. And on the right-hand side, you just have t e to the t. So this implies that a is equal to 1 over 6. And so xp is just going to be 1/6 t cubed e to the t. And now step 3 is to combine this all together. Step 3 is to say x of t is equal to the solution to the corresponding homogeneous equation, which is c1 e to the t plus c2 t e to the t plus the particular solution to the non-homogeneous equation. So 1/6 t cubed e to the t. This is the final answer.